Today on Flipping Science, we're looking at changing concentrations. So today on Flipping Science, we're looking at converting concentrations. So we're going to start with moles per litre, we're going to change that into grams per litre, change that into percent weight for volume, change grams per litre into parts per million, and change parts per million into parts per billion. So let's start by looking at how to change moles per litre into grams per litre. So we have moles per litre, we want to change that into grams per litre. To change moles per litre into grams per litre, we need to multiply by the molar mass. The reason for that, if we look at the molar mass unit, the molar mass unit is grams per mole. Okay. Now, if we have a look at this, we can see that we can cancel things out if we do this multiplication. So I can cancel out the moles here, and then I'm left with grams per litre, which is the unit that we want. So let's do an example question. I've got 2 moles per litre of sodium hydroxide, and I want to turn that into grams per litre. So I want to find how many grams per litre are in 2 moles per litre of sodium hydroxide. So I'm going to multiply by 2, so this is our 2 moles per litre. I'm going to multiply that by the molar mass of sodium hydroxide. To find the molar mass of something, you look at the atomic mass on the periodic table and you just add them together. So I'm going to do 2 times, I'm going to put it in brackets. The molar mass of sodium is 22.99. Molar mass of oxygen is 16, and the molar mass of hydrogen is 1.008. So I'm going to shove that into my calculator, and I get and I get 80. So 80 grams per litre, rounded off. So in 1 litre of 2 molar sodium hydroxide, there are 80 grams of sodium hydroxide dissolved in it. The next conversion we're going to look at is taking grams per litre and turning it to percent weight for volume. Percent weight for volume tells you how many grams you have in 100 grams of a substance, or how many grams you have in 100 mils of a solution. So to do the conversion of grams per litre to percent weight for volume, what we need to do is divide by 10. So let's see where that comes from. So if we've got grams per litre, and we want to turn that into grams per 100 millilitres, all right. We look at how many lots of 100 millimeters are there in a litre, and there's 10. So if we divide this by 10, that tells us how many grams per 100 milliliters we have. This works for mass as well. So if we had grams per kilogram here, we could divide it by 10. That would tell us how many grams per 100 grams we have. So here's our next example. I've got my concentration of sodium hydroxide is 80 grams per litre. What's the concentration of sodium hydroxide in percent weight for volume? So I'm going to take my 80 grams per litre, I'm going to divide that by 10, so that's our conversion here, we're dividing by 10, there's 10 lots of 100 mils in a litre, and I get 8% weight for volume, so 8 grams per 100 millilitres. So in an 80 gram per litre solution of sodium hydroxide, there's 8% sodium hydroxide in there, so 8%, 8 grams per 100 millilitres. The other conversions I'm not going to go into detail with. Suffice to say that when we go from grams per litre to parts per million, we need to times by 1,000. When we go from parts per million to parts per billion, we times by 1,000 as well. The reason for that is there are 1,000 milligrams in a gram, and parts per billion is 1,000 times smaller than a part per million. So that's where we get those units from. So now let's look at some examples where we can convert from any one of these units into another unit. So in this example, we're converting cadmium ions from 1200 parts per million. We need to convert that into moles per litre. So we're taking parts per million and we're going to turn it into molar concentration moles per litre. So if we have a look at our way of doing that, we're going to first divide by 1,000 to go from milligrams per litre to grams per litre. Then we're going to divide by the molar mass of cadmium to get us back to mole per litre. So let's start that. So we've got 1200 parts per million. We're going to then divide by 1,000 because remember parts per million is milligrams per litre. There's 1,000 milligrams in a gram. So divide by 1,000, and then after that we're going to divide by the molar mass of the moles per litre. But we'll do this step first. So 1,200 divided by 1,000 is 1.2. Alright, so then we've got 1.2 grams per litre, so we're back to this step. Then we're going to take grams per litre and we're going to turn it into moles per litre, so 1.2, and we're going to divide that by the molar mass of cadmium. So I'll look that up on the periodic table and I'll write that in. So the molar mass of cadmium is 112.4, so 1.2 on my calculator, 1.2 divided by 112.4, and I get 0.0107 moles per litre. And you can start to see why we use parts per million instead of moles per litre, because we're starting to get really small numbers here. So that's one of the reasons why we do it this way. Let's look at another example. So in my next example, I have a vitamin C tablet, and its concentration on the packet is 0.04% weight for volume. I'm trying to find the concentration of that vitamin C tablet in parts per billion. So let's have a look at the conversion that's going to take place. So we're turning from percent weight for volume, so that's gram per, in this case because it's a tablet, it won't be 100 milliliters, it'd be 100 grams, so grams per 100 grams. We're taking that into grams per kilogram, so there's 10 lots of 100 grams in a kilogram, so timesing by 10. Then we're going to times that by 1,000 because there's 1,000 milligrams in a gram, and then we're going to times that by another 1,000 because there's 1,000 micrograms in a milligram. So that's our conversion process. So let's start working with our numbers. So we're going to take 0.04% weight for volume, and we're going to times that by 10 to get us back to grams per litre. We're going to times that by 1,000 to get us to parts per million. Then we're going to times that by another 1,000 to get us into parts per billion. So I'm going to shove that in my calculator and see what I get. So I've got 0.04 times by 10 times by 1,000 times by 1,000, and I get 400,000 parts per billion. So 400,000, there we go, parts per billion. Right. So again, you can see why this is a handy unit, because we're not using as many numbers here, so it's an easier number to print on a package, for example. Let's look at one last example. So in our last example, I have an aspirin tablet that's got 60 milligrams of aspirin in a half gram tablet. So we're trying to find the concentration of aspirin in grams per kilogram. So when we're looking at our conversion here, we're looking at percent weight for volume, because we want to figure out what percent of aspirin is in this tablet over here. Then we're going to times that by 10 to get us to grams per litre. We're not looking at grams per litre again, because we're looking at a tablet, we're looking at grams per kilogram. So that's our conversion there. So the first thing I'm going to do is figure out what our percentage weight for weight, because we're going to use weight for weight up here instead of weight for volume, percentage weight for weight of aspirin is in the tablet. So we're going to find a percentage. So to do that, you figure out how many grams you have in a gram. So at the moment we have 60 milligrams in a 0.5 gram tablet. Now that's problematic because we want to have the same unit on both sides. So we need to figure out how many milligrams 60 milligrams is in grams. So to do that, we're going to use a conversion. We're going from milligrams to grams. To do that, we need to divide by 1,000. The reason why we do that is there are 1,000 milligrams in a gram. And dividing, we're going from a smaller unit, a milligram, to a gram. So if I pop that in, I don't need a calculator for that. So 0.06, 0 because we've got 0 in the end there. Grams divided by 0.5 grams, and to turn that into percentage we need to times by 100. It's like you would be calculating the test score, and if you do that you get 12% weight for, in this case, weight for weight, because it's a tablet, it's solid. So the last step is we're going to take this 12% weight for weight from here and we're going to turn that into grams per kilogram, which is the unit that we want. So to do that we're going to times by 10. So we've got 12% weight for weight. We're going to times that by 10, and that will turn us into grams per kilogram. So 12 times 10 equals 120. So it's 120 grams per kilogram. So if our tablet is 12%, so then that means there's going to be 120 grams in a kilogram of tablets. So today on Flipping Science, we looked at doing some concentration conversions. That's it for Flipping Science today. See ya.